bit more on angular motion. We'll talk a bit about centrifugal clutches, although some people think that centrifugal doesn't exist because it's a reaction to centripetal. But they are such things. A centrifugal clutch, you don't really need to know what clutches do, although you drive cars, most of you, so you should imagine you know what a clutch does. It engages power, or it enables you to transmit power from one thing to another. So if you're going down a hill and you've got your car in gear, the engine will sort of control you going down the hill. Whereas if you put your clutch in, so you disengage the engine, your car will get faster and faster and faster because there's nothing to slow it down. So they usually teach you to slow down using gears because you're in more of a controlled environment that way. It's at least what they teach you in tests anyway. So all a centrifugal clutch does is transmits power by using centrifugal force. These type of clutches are used in lawnmowers, trimmers, things like that. You don't need to know the ins and outs. So all that happens is this bit here is the input shaft, which is spinning, and it's got attached to it two masses in this case, right? Because like a cross section diagram and it's attached by some springs. So there's springs here. So this is the input power, the input shaft spinning, and then this bit, the red bit, is like the output bit, and that output drum look is attached to an output shaft. So this blue thing spins and pushes these springs out, depending on how stiff the springs are and how big the mass is and how big the gap is. These things will spin out, and in the end they will touch. Due to centrifugal force pushing them out and friction, they will touch and engage this outer bit. So at a certain RPM, these springs will be pushed out, the masses will be pushed out. They stick due to friction and force onto this sort of red drum and engages that power. So it's all spinning, then that power then is transmitted to this output shaft here. Look. So we can work a few things out. D2 is just like the diameter to this in bit here. Look. So D's diameter, that is radius really if you think about it. S is the spring stiffness, because the stiffer the spring, the more RPM you need, the more force you need to get it to move. M is just these masses. R0 is from the center of this shaft to the center of that mass. So how far from there to there. And X is the clearance between the end of the mass, so which is there really, to the drum here. It's not from the center of the mass, it's from the end of the mass to the center. So we don't really need to know how big the mass is in size wise. So R0 is going to be in meters or millimeters. X clearance is going to be in millimeters or meters. M is kilograms. Stiffness is newtons per meter. Kilonewtons perhaps. So obviously this will engage at a certain RPM, so we can work out that RPM, that these masses will engage. Obviously the force to engage this, we need to work that out, because it's due to the spring stiffness and the clearance. And we can also work out the torque produced. Don't worry about that formula, right? We can break that down, and we can also use power. Work out the power transmitted. So with this formula here, N is number of masses, mu is the friction, because you've got friction between that mass and this drum. M is a mass. This omega is just an angular velocity at a certain speed. These two are just these two here. F is the force, the spring tension, which we can work out, and D is diameter, and 2 is just 2. So we can work out torque, we can work out angular velocities, this thing that engages at, because this thing will engage at a certain angular velocity. And we can work out power. So we can work out the spring tension, which is going to be S times X. Now S is just the spring stiffness, which will be given to you. Sometimes the spring stiffness is K. I think in my notes I put down K or S, but it's just how stiff the spring is, times by the extension, which is just this X here. Because this mass has got to go out a certain distance to engage with that, which is this extension X. And when it does engage, it starts to spin this output shaft. So we can work out as well the angular velocity when the mass is engaged with the drum, because you could spin this, and due to the friction and due to the spring stiffness, they won't move. It's only at a certain RPM that they'll be pushed out and engaged, which is this formula here. So this is angular velocity, which we know about. F is just force, which we've just worked out here. M is the mass of this, of 1. And R0 plus X, that should be R0 plus X, like that. So really, it's this number here plus this number here. Now, it's not equal to the diameter because that R0 is only going to the center of the mass. But that's all that there is. R0 plus X is just that number there plus that number there. That'll give us the angular velocity at which these masses engaged. And then we can use this formula to work out torque. Torque produced by the centrifugal clutch at a certain angular velocity. Obviously, if these things haven't engaged, there's no torque produced. So if this number here comes to, say, I don't know, 123 radians per second, then we can work out the torque produced at that number using this formula here, which we'll get onto in a bit. And then power, we can work out the power at a certain angular velocity. That's angular velocity, and this is torque, which we'd have worked out here. So it looks a bit tricky, but once you do a few examples, it's not too bad. So all we're going to be using really is step by step, that formula first, that formula second, third, fourth. In, die, tree, padwa. Don't forget, everything's got to be in meters. We need everything in meters. We like things to be in radians per second. That's drawing that, but radians per second. So there's a couple of questions that I've on here. So I'm going to do this one. I'll do this one. And then can you lot then do this? Right? Number one, sorry. I'll do number 1. Then you can do number 2 and number 3. Now, they're all very similar, all using the same sort of formula. Bit of practice for you. So I'll do number 1, then you use that example to do number 2 and number 3. So I'm doing number 1 now, and number 1 is here, just like in repeater. So number 1 is here, look. So if you look, let me just minimize that one as well. Let's get this down like that. So if you look, so here's my rotating masses, 0.25, 0.25, right? Spring stiffness 8, so there's 8. Output shaft is 5. Diameter is 300. So this is the question I'm doing, 135 and 0.35. Calculate the speed in RPM, which it transmits power. That's part A. And then I'll do torque and power down here. So that is the question I'm doing now. The answers are in the brackets for this one. And then once I've done number 1, then you can do number 2, number 3 and hand it in on Moodle, please. So all the formula I'm using are from here, 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 and yeah, 1, 2, 3, 4 formula. So that's what I'm about to do now. I'm going to turn over to this. Get a calculator up. Let's move this about a bit. Let's go to there. Let's go to there. Scroll down. Okay, cool. So question number 1 on that sheet. So make sure you got the sheet in front of you. What's going on here? Let's do something with this. Right. So Barrod, let's go. So we've got a clutch, 2 rotating masses. So M is going to be 0.25 kilograms. The spring stiffness is 8 kilonewtons per meter. It's either going to be K or S. In our case, it's S because we've got kilo and we've got, kilograms. So S just means spring stiffness. The initial clearance is 5 mil, so that's our X value. The inner diameter is 300 mil. That's going to be our D value, diameter. The center to the masses, so the center of the center of gravity of the mass is 135 mil. That's R0, and the friction is going to be 0.35. Obviously, these have got to be in meters. We'll convert them into meters soon. That's the correct unit there. Don't forget 8K means 8,000. 0.25 is in kilograms. So we need to work out the RPM now, in which clutch begins to transmit power. So this thing is going to spin. The masses are going to move out, and it's going to transmit power at a certain RPM, which we need to work out. Part B, we need to calculate the torque and the power transmitted at 1,000 RPM. So we'll do first the RPM in which the clutch starts to engage and transmit power. And then we'll work out the torque and power that the clutch transmits at 1,000 RPM. So the first formula we've got to use, because this formula here will give us the angular velocity at which the clutch will transmit. So that's from the sheet. So that's F, that's the mass, this is the 2 distances. So we know M because it's up here. There's M, look, 0.25. We know R0, which is here, 135, and we know X, it's there. F, we don't know F, but we can work out F from our formula. So F is going to be the spring stiffness, S, which is up here, times by X, which is the clearance, which is 5 mil. So S is 8 kilonewtons per meter, which is 8,000, look, 8 kilo, times by the clearance, which is 5 mil. So that's 5 mil in meters. 5 divided by 1,000. So that times by 8 kilo, this will give us the spring force, which is 40. 40 newtons, which is the number I'm going to put in by there. So now we know M, because it's 0.25, we know R0, it's 135, and we know X is 5. So to find the RPM, or the angular velocity in which the clutch transmits power, here's the formula. So F is 40. 0.25 is the mass, which is there, look. And then we're going to need to do R0 plus X, which is 135 mil plus 5 mil. Don't forget to get into meters. So really 135 plus 5 is going to give us, saves you put it into the calculator, that's going to give us 135 plus 5, 140, times 10 to the minus 3. Because it's 135 mil plus 5 mil, which gives you 140. So 140 millimeters in a meter is, okay, 100, right? You can put that in, just saves you putting that in, really, just to be easy on the calculator. So this will give us the angular velocity in radians per second. Obviously we need RPM, so we've got to do a bit to it down here. So on your calculator, we'll go this way. So square root 40, divide that by 0.25 times by my 135 plus 5 gives me 140. So we'll put that in, saves extra step. That gives us that. Come to there. This will give us 33.8. So that's 33.8 radians per second, which is okay. That's the angular velocity in radians per second that this clutch will start to transmit power. We got to put it in RPM because we still use RPMs, although it's not the SI unit. But when we talk about clutches, we'll use RPMs. So don't forget to go from a radian per second into an RPM. We've got to divide it by 2 pi over 60, which we've done before. So to convert a radian per second into an RPM, we divide it by 2 pi over 60. I won't go into why that is because we've done it before. So 33.8, so let's do this. 33.8, divide that by 2 times shift pi, divide that by 60, it should work out that bracket. 323, there we are. So 323 RPM. So 33.8 radians per second is the same as 323 revolutions per minute. And that is the RPM that this clutch will start to transmit power. So that's part A, ready Benny, finished. This part B is the torque and the power transmitted at 1000 RPM. Now, this clutch is going to engage at 323. So anything below that, it's not engaged, it's not transmitting power. Everything above that, it is transmitting power. So we need to work out now the torque and power at 1000 RPM. You could work it out for that, but we've been asked to work it out for 1000. So 1000 RPM. So torque at 1000 RPM. So we need to be in radians per second. So just like we've done previously, to go from an RPM into radians per second, you multiply it by 2 pi over 60. So 2 times shift pi equals that. Divide that by 60, times that by 1000. So 1000 RPM is the same as 104.72 radians per second. Because that's the formula we got to use, that's the number we got to use here. So it's asking us the torque and power at 1000 RPM. Now 1000 RPM is the same as 104.72 radians per second. So that's the number we're going to use now for omega down here. So the torque, now don't worry about this formula because I break it down slowly. As long as you get the brackets the right way, if you're going to do it in one go, or you do like I've done and just break things down a bit. So the torque is going to be N, which is the number of masses, which was 2. So mu is the friction coefficient, which is 0.35 from the question. M is the mass, 0.25 kilograms. Omega is this number here, because this is the number. So where it's asked the torque at 1000 RPM, we converted 1000 RPM into 104 rads per second, and that's the number I'm going to put in there. If you wanted to work out the torque at that number, you'd have to put that number in here. Obviously, it's got to be in radians per second. So if you wanted to work out the torque transmitted at 33.8 radians per second, you would put that number in by there. In this case, it's going to be 104 because it's 1000 torque at 1000 RPM, which is 104 rads per second. R0 plus X is just our numbers again, which are going to be 135 plus 5, which gives us 140. So I'm going to put 140 in there. Take away F, which we know is 40. D divided by 2 is just the diameter, which is 300 from the question, divided by 2, which is 150. So 300 divided by 2 is 150 mil, and then that is it in a meter. So I've worked that bit out, which is going to be 140, so I'll put 140 in there. This d over 2 I've worked out to be 150 times 10 to the minus 3. Just saves us putting extra steps in. You can do all in one go if you want to, if you're happy with using brackets, because it's going to be n times this times all of that times by that. So let's go down a bit, put my numbers in. So 2 is the number of masses, 0.35 is the friction, and then we've got a mass is, 0.35 is the friction and 0.25 is the mass, times by omega squared, which is from the top, 104, don't forget the square, times by R0 plus X, which is 140, take away F, which is the force, which is 40. So it's 2 times that, times by all of this. Make sure you do that. So all of that times by this, times by d over 2, which is 300 over 2, which is 150 in a meter. So step by step, obviously you can do all of that in one go if you want to. So 2 times 0.35 in my book is 0.7. And then all of this, so 0.25 times by 104.72 squared times by, let's put a bracket on that just in case. Close that, take away 40 equals 343.82. Now obviously it's better if you keep it all, because it's a bit more accurate. So I'll keep it there. Now it's there, I'll keep it in there for now. So now it's all of that, which is, I've got 82 there, look, so I'll keep this number in, times by 150 minus 3 equals that, times by 0.7. Gives me 36.1 Newton meters. So that is the torque produced or transmitted when this clutch is spinning at 1000 RPM. That's how much torque would be transmitted to the output shaft. So although this formula looks like really pain, but if you break it down like I've done, it's not too bad. As long as you make sure the brackets, this bit here is done first, times by that, times by that. That's the torque. Now we've got to do the power. What is the power transmitted? So the power transmitted at 1000 RPM, so here's my formula for power, is omega t. Omega is just the angular velocity, which is going to be 104. And the torque is going to be what we just worked out, 36.1. So there's my torque, 36.1, look. I'll keep that in there. Times by the angular velocity, which is, again, 104.72. Yeah. So it's 36.1 over here, look, times by 104.72. I leave my torque in there, a bit more accurate. 104.72. This will give me the power. So 378. So a slightly different bit, right? But 378 watts or 3.78 kilowatts. That's how much power will be transmitted by that clutch. Power to the output shaft. So that is centrifugal clutches, an example of. Like I say, there's only really that formula you need to use from the start, then this formula, then this formula, then this formula. So it's not too bad. This is the one you may slip up on because it's got some brackets, so you just need to make sure that you take your time over this one. Do it a few times just to make sure you get the answer. Make sure everything's in the right units, millimeters, and convert that to meters. kilonewtons if you've got kilonewtons. So can you please now have a go at that one? Sorry, I've just done that one. Have a go at these, number 2 and number 3, os gwelwch yn dda. That means, if you please, in Welsh, if you're watching in another country. Centrifugal clutches, yes, there will be a question in an assignment somewhere sometime, so please have a go. Any problems? Over and out. Yes, goodbye.